Hello people, I'm Bharat Acharya. Welcome to a new video. So in today's video we're going to learn 8085 programming. I'm going to teach you basics of programming and then I'm going to take it to a higher level. We'll start with a simple program first to add two numbers. We'll do it in the most simple way, using LDA and STA instructions. These are the instructions people who start programming use. Okay, they are the most basic way of doing a program. Then after we finish that, in that program of course we're going to take care of carry also, so I'm going to teach you how to handle carry. Now carry is not something that happens in one program. If you know how to handle carry, you'll be able to do it in various programs because that situation arises across 40 to 50% programs that you do. Then I'm going to teach you the same program of add two numbers but how to do it in a professional way. College exam, you do it either of the two ways, you'll get full marks. But your life doesn't end with adding two numbers. You want to do serious programming. Now when you want to do serious programming, you want to start using M, the memory pointer. That's the strongest tool of 8085 programming. So I'm going to teach you with this example of adding two numbers, how to do the program using M. Once you know that, you'll be able to do big programs which involve major loops because in those programs, M becomes your best asset. Anyway, after that, we're going to take it a level higher. I'm going to do block transfer programs. These are regularly asked questions. So first we're going to see a normal block transfer, transferring a block of data from one place to the other. Why does this program keep coming a lot? Because where is it used? It is used in copy paste. Now copy paste is something that we do every day. So when you're doing it next time, you copy a set of data, Control-C, Control-V or Command-C, Command-V if you're using Mac. When you do that, you should strike your mind that I know how to write the program for doing it. So I'm going to anyways teach you a normal block transfer. Then I'm going to teach you inverted block transfer. The block of data containing 1, 2, 3, 4, 5, when it's inverted, it should be 5, 4, 3, 2, 1. So it's also called infix, postfix or string reversal, whichever way. Different universities call it different way, but basically it's an inverted block transfer. Then I'm going to show you how to exchange two blocks. This is a whole block of data, this is another block of data. By the time the program is over, this should be here, this should be here. So that's what this video is going to be all about. Okay, so our first program is to add two numbers. So this is how the question will be there in the exam. Write a program to add two numbers. Either they will give the addresses or you assume. So let's say the numbers are stored at in the memory at the location 2000 and 2001. Now both of them contain 8-bit numbers. You tell me, when you add two 8-bit numbers, answer is how many bits? Exactly 8 bits. Like when you write add B, operation is A plus B, the result comes in A. So answer is 8-bit, no doubt. That is called the sum. And there is a possibility of a carry. Now what are the possible values of carries? 0 or 1. You get this clear? Carry can never be 2. 9 plus 9 cannot be 20. 99 plus 99 cannot be 200. Similarly, in hexadecimal system, both these numbers are 8-bit numbers. So worst case situation, there will be FF. FF plus FF is 1FE. Like 99 plus 99 is 198. Similarly, FF plus FF is 1FE. In 1FE, FE is the sum, 1 is the carry. So basically, carry can only be a 0 or a 1. So you got to store both sum and carry. So they will be requiring two locations, 8-bit for the sum, and though carry is 0 or 1 will be stored as a separate location. So we'll be storing sum at 2002 and carry at 2003. Now here is another thing to understand. If they don't tell you where to store the sum and carry, please store it correctly. There is a rule followed always. Lower byte, lower address, higher byte, higher address. Say this again please. Lower byte, lower address, higher byte, higher address. Now 2000 and 2002 and 2003. This is the lower address, this is the higher address. So here the lower byte should come, here the higher byte should come. Now between sum and carry, which is higher? The carry, of course. Why? Carry comes after the MSB of the sum. So it is the higher byte. Like for example, 9 plus 4 is 13. 13 means 3 and a carry 1. Now 3 is in the units place, 1 is in the tens place, so it is more significant. So it is called the higher byte. Are you clear? So we will store the carry over here as the higher address, the higher byte at the higher address, lower byte at the lower address. Now what's the procedure? As I said, I'm going to do the program in the simplest way possible. Now I have an advice, okay? Right now, just disconnect from everything else that you're doing and focus here, especially if you have never written 8085 programs. Okay, once you understand one program completely, it will give you massive confidence to understand more programs. And you never learn programs, you learn programming. I'll be teaching you a lot of skills over here, which only if you're fully concentrating, you'll understand every word I'm talking. Okay, so please pay attention and disconnect from everybody else. Now you want to add these two numbers. Obviously, to add them, first of all, you'll need to take them into registers. So what are you going to do? Take the first number into some register. So here is your first question. You'll take it in which register? Tell me. There are 7 registers, A, B, C, D, E, H, L. You'll take this number in which register? Yeah, A. Why will you take it in A? Because the instruction to do this is called LDA. Get this clear, my friend, there is no LDB or LDC. So what is the first thing you understood from here? Whenever you want to take data from the memory, the register in which you will get the data is A. The gateway into 𝗵𝑝 is A. Once the data comes in A, you can transfer into any other register, but it will come in A. Are you clear? So take the first data in A. Now, immediately transfer it into some other register like B. Why? Because you're going to take the second data also in which register? A, exactly. So when you take the second data in A, you don't want to lose the first one. So take the first number in A, transfer it into B, take the second number in A. Will you be able to do instructions for doing this much? Good. Now, add these two numbers. Add B, so it will do A plus B. The result will come in A. What is there in A? The sum, which we're going to store at 2002. At 2003, we're going to store the carry. Assume the carry is in C register. We will get it, of course. Now, assume the carry is in C register. We'll store the sum from A to 2002 and the carry from C to 2003. So now the only thing left in our mind is how to get the carry in C register. That I'll teach you as we do the program. First, let's do the instructions for doing this much. Come on. Get the data of 2000 into A. Come on, give me the instruction. LDA 2000H. Please tell me, did you understand this? So A gets the data from 2000. Immediately transfer the data into B. Move B, A. Exactly. Was it move A, B or B, A? B, A. I always tell this in the class. See, right now I can't see you, but you got to follow this if you want to learn properly. Say instructions. There's a big difference between thinking of them and saying them. When you think of them, you're 50-50 about what you're going to say. When you say, you commit. So what happens? Either you'll end up being right or wrong. If you're right, great. If you're wrong, great, because now you know what is wrong, so you will not make the mistake again. So much better than just thinking of it is saying instructions. Okay, it's going to help you. Okay, so you took the first number in and transfer into B. Take the second number in A. Come on, give me the instruction. Second number in A. Good. LDA 2001. Now you've taken your two numbers in A and B. Now add A and B. Come on. Add B. Exactly. Now when you did this, who has what? A has the sum. The sum is in A. Store the sum at 2002. STA 2002. Please tell me, did you understand this? We have stored the sum in 2002. Assume the carry is in B. I will put it. Can you see I have left space? I'll put it. First, let's just store the carry. Assume the carry is in C register. The carry is in C. From C, you're going to store it at 2003. How are you going to do it? From A, you store it at 2002 by writing STA 2002. From C, you'll store it at 2003 by writing STC 2003. No, there is no such instruction. There is an STC, but that is set the carry flag. That is not store C register. So what did you understand? If you want to transfer from C register to a memory location, you have to first get it into A register. Exactly. What did I say? I am the 𝗵𝑝, you are the memory. Between the two of us, there is A register. I want data from memory, it has to come into A. From A, it will go wherever you want. Similarly, if I want to send data to memory, I have to put the data in A and write STA. There is no STB or STC or STD. Are you understanding what I'm saying? So, from C, first take the data in A. Now, come on, give me the correct instruction. You want to transfer the value from C register to A register. Come on, come on, come on, come on. Move A, C. You always write the destination first. It's destination, source. So, you'll transfer from C to A. Now, from A, you'll store it at 2003. STA 2003. Done. End the program by writing halt or return or RST1, whatever your college teacher writes. There are different ways of ending the program. Most common is halt, so I'm writing halt. So now the only thing left to be done is get the correct value of carry into C register. Now who has the carry? The moment we do this addition, carry comes into the carry flag. So what we need to do is from the carry flag, get the carry into C register. I repeat, from the carry flag, get the carry into C register. Did you understand this? From carry flag, get into C. Now, can you write move C, carry flag? No, that is not possible. There is no such instruction. So, here you need to use some logic. If carry flag is 1, make C register 1. If carry flag is 0, make C register 0. Did you understand this? We've already done the code for storing C register at 2003. Our job is just to get the correct carry into C register. So, I say again, if carry flag is 1, make C register 1. If carry flag is 0, make C register 0. Now, C register can have only two final values, 0 or 1. Don't try to find out both values. That is stupid programming. We say this, when you see somebody's code, you come to know instantly whether that person is serious about programming or is just writing to get it done with. If you know something can have only two values, never try to find both values. Assume one and work on the other. That makes your work half. C register could have only two values, a 0 or a 1. 𝗵𝗍𝐶, I have started my program by assuming that there is no carry. What does this mean? If there is, after this addition, if there is no carry, my program is already working without doing anything. There were only two possibilities. There could be either a carry or no carry. I have assumed no carry. So if there is no carry, I have to do nothing. Please tell me, did you understand? So now I have to handle two cases or one case? Only one case. Which case? If there is a carry. Now, if there is a carry, C register should become 1. To make C register 1, you can write 𝗵𝗍𝐶, 01, or you can write INRC. What do you write? INRC. INC was used in 8086, so you write INRC. Now when you write INRC, INRC stands for increment C. Now this line, increment C, should be written only if there is a carry. If there is no carry, I should not do this. So come here. You initialize C with 0, you took your first number, transferred into B, took the second number, added it. Here you have to make a decision. If, I am saying it in English, then I will write the instruction. If there was a carry, I should do this and continue. If there was no carry, I should jump over this line and continue. Please tell me, did you understand this? If there was a carry, I should do this. If there was no carry, I should jump over it. The instruction is JNC skip. This is skip. JNC stands for jump if no carry. I repeat, jump if no carry. So if there is no carry, directly skip and store the result, because you assume C to be 0, it is valid. If there is a carry, it will not jump, because I have said jump only if there is no carry. So if there is a carry, it will not jump. Now if it will not jump, what will it do? Will it sit there? If it doesn't jump, it by default it will go to the next location. That means it will make carry 1 and then go ahead. That means bottom line, this instruction will only be executed if there is a carry. If there is no carry, you will skip this instruction. Please tell me, did you understand this? Yes, is the idea of handling a carry clear? That was the thing I wanted you to learn from this program. Carry is not something that happens only in this program. You will come across the situation of carry in 25, 30, 40, maybe 50% of programs that you do. After this, in any program, if there is a carry, this is how you're going to deal with it. What's the procedure? Tell me. Take a register like C. By default, initialize it with 0. So you assume that there is no carry. Do whatever you want to do till the part where carry could be produced. Now here you want to check carry. If there is a carry, increment C register. If there is no carry, jump over the line where you are incrementing C register. What is this label? Skip. It's a label. You can give it any name you want to. Because I am skipping an instruction, I have given the name skip. You could have called it down, then you will be writing JNC down. That's just the name of a label, whatever you want to do. You're not skipping because I have written the name skip. You're skipping because of this instruction JNC. JNC stands for jump if no carry. So for the last time, let's just repeat the program, then we go ahead. You've initialized carry as 0. You've taken the first number in A, transferred the number into B. You've taken the second number in A. You have added the two numbers. I think up to here everybody is okay. Now at this point there could be two things, either there could be a carry or there could be no carry. You assume that there is no carry because you initialize C as 0. So if there is no carry, directly jump and come over here. If there is a carry, make C 1 and then come over here. So by the time you've come over here, C register has your actual carry. A has the sum, C has the carry. Store A at 2002, STA 2002. You want to store C at 2003 but cannot be done directly. So from C first get the number into A, from A store it at 2003. From C get the number into A, from A store the carry at 2003 and end the program halt. That was your program. Please tell me, did you understand this? So this was a program to add two numbers. Now what are we going to do next? Again a program to add two numbers. Why are we doing it again? This is how a college student will do a program, or a child, a person who has started programming, first day of programming. This is how he or she will write the program. If you ask a professional to do this, which is what you are going to become, which is what you are aspiring to become. Tomorrow you want to be a person who gets paid for writing programs. You want companies to hire you, sit over there, write good programs for them. If you give this program to a professional, they will have a good laugh over it. You don't do programming like this in the real world. Yes, you start learning programming like this. This is the basic tools. You got the idea of to work with registers. If you want to do real serious programming, you have to start using M. M stands for what? Memory pointer. M is the best tool of programming. Whenever you want to access a series of locations which you need to do for real world programming, you need to use M. There are various programs which can be done only using M. So the sooner you start learning M, the better position you are in when you get into complicated programs. Now I don't want to introduce M when I'm doing some real crazy logic, because A, you'll be struggling with the logic, plus you'll get confused with what M is doing. So a program that you've already done, I'm showing you how to do the same program using M. The moment you'll finish, you'll realize how wonderful this approach is as compared to this approach. Here you are tied up with a lot of rules. Here it gives you a lot of flexibility. Anyway, so we are about to start the same question again. Okay, so the exact same question. Write a program to add two numbers stored at 2000, 2001. We will store the sum at 2002 and we will store the carry at 2003. Exact same situation, but now we're going to do it using M. Now how do you work with M? M is the data of the memory location pointed by HL pair. Say this again. M is the data of the memory location pointed by HL pair. So if you want to access these memory locations using M, you need to first initialize HL pair. Your first step is make HL pair 2000. How do you do that? 𝗓𝗪 h, 2000. 𝗓𝗪h. What does 𝗓𝗪h do? Load immediately. Load immediately into HL pair the value 2000. For HL pair 2000 is data. You put the data 2000 in HL pair. That will now act as an address. Whatever is the number present in HL pair acts as an address whenever you use the word M. So because HL pair is initialized with 2000, you can refer to this quantity using M. Now M is this location's data. Is that clear? Now what can you do with it? Look here. Move A, M. By doing this, you have taken this first number into A. Student will say, so what's the big deal? We took the first number in A over here also. Yes. Here you can only take the number in A because you can only write LDA. There is no LDB or LDC. But here you can write move B, M and get this number in B. You can write move C, N and M and get this number in C. Are you immediately understanding because of using M you're getting more flexibility? Of course, this is just the beginning. There is so much more advantage of using M, which I'm going to teach you. This just happened in the very first line. So when you write move A, M, you have taken the first number in A. Please tell me, did you understand this? So you got your first data. Now, you want the same data or the next data now? Next data. How do you get that? Make HL pair 2001. The moment you make HL pair 2001, this number will be called M. Did you understand this? How do you make HL pair 2001? Come on, come on. 𝗓𝗪h, 2001. No, my friend. This is so much easier. INXH. You know what is INX? Increment HL pair. When you write INXH, HL pair which was 2000, now HL pair has become 2001. Because HL pair has become 2001, M is now the second location. Please tell me, did you understand this? Now what? The first number is in A, the second number is M. Add them. Instruction. Add M. Did you understand what happened? The semicolon is not required. If you want to write a comment, you write put a semicolon, otherwise it's not required. So when you write add M, you added these two numbers. So what has happened? Here we kept taking numbers into registers and then adding them. Here you are directly adding the value of a memory location. Did you understand what M made you do? You didn't even take the location. You're directly adding that location's data to A register. So does it reduce your steps of programming? Of course it does. This is a much better program than that. And this is a trick that will help you write much complicated programs in a very easy way as compared to using that approach. In fact, there are some programs where you cannot use this approach at all. But here you can do a lot by using M. Let me just finish the program, then I'll teach you more. I'll show you more advantage of using M. Anyway, so when you write add M, these two numbers have been added. Now what? When you added them, the answer has come in A. What does A have? The sum. Now you want to look for the carry. The same trick. Don't look that side, no cheating. How do you handle carry? Come on, tell me. Initialize a register like C with the value 0 right in the beginning of the program. If there is a carry, increment C. If there is no carry, skip that line. Just jump over that line. Remember that or no? Come on, same thing. 𝗕𝗵𝗿𝗁. You assume that there is no carry. If there is a carry, I will increment C. If there is no carry, if there is a carry, I will increment C. If there is no carry, I will skip. Jump if no carry to skip. So by the time I have reached skip, who has what? A has the sum, C has the carry. I repeat, A has the sum and C has the carry. So all you need to do is store both of them. How do you store A at 2002, ST at 2002? No, I want to stop using direct addressing mode. I want to do everything using M. HL pair is right now 2001. Just increment HL pair. INXH. HL pair will now become 2002. Please tell me, did you understand this? Now, HL pair is 2002. That means this location is now called M. Store the value from A at this location. How do you store from A to that location? Move M, A. So you stored your sum. Again, INXH. Again, increment HL pair. HL pair now becomes 2003. Store the value of carry at this location by writing move M, C. Did you see the advantage? You can store carry directly into this memory location. In this previous program, from C first you had to take it into A, and from A you had to store it over here. Now that problem is solved. You are directly storing the value of C register into a memory location. These are the advantages of using M. Program is over, job done, halt. This was the same program using M. This is the same program without using M. Let's see advantages. What's the first advantage you understood? Come on, I'll tell you there are lots of advantages. First advantage, you can only work on A register. Data can only be taken into A or stored from A. Whereas over here, you can transfer data using any register. So it gives you flexibility. You're not over dependent on A for everything. Did you understand? That was the first advantage. Second, let's look at the size of the program. Yeah, on the face of it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 instructions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, this looks bigger. Oh, no, it is only looking bigger. It is not bigger. See the size of the instructions. I have taught you how to figure out size of an instruction. If an instruction doesn't have a number, it is a 1-byte instruction. If there is a 1-byte number, it's a 2-byte instruction. If there is a 2-byte number, that means a 3-byte instruction, because numbers are never a part of the opcode. They are written separately as operands. I have taught you all of that. So look at the size of this program. This is 2-byte, this is 3-byte, this is 1-byte, this is 3-byte, this is 1-byte. This is an address. You know that, right? This is an address. So 1 and this is 2 bytes. So that means this is 3 bytes. This is 1 byte, this is again 3 byte, this is 1 byte, this is again 3 byte, this is 1 byte. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22. This is a 22 byte program. Compare that to this one. This is 2 byte, this is 3 byte, this is 1 byte, this is 1 byte, this is 1 byte, this is 3 bytes because this is an address. This is 1 byte, this is again 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 1 byte, and this is 1 byte. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This is 17 bytes as compared to 22 bytes. So is this a smaller program? Yes. Does it make a difference? Of course it does. Apps which are smallest in size load the fast, refresh the fastest. The lesser the space you consume, better the programmer you are if you manage to do the same thing in lesser code or lesser number of bytes. So that is it. None of these are really the advantages that I'm talking about. Yes, they are advantages, but real big advantage lies here. This is a program to add the contents of 2000 and 2001, store the sum at 2002 and 2003, correct? What if I change my question? What if I tell you add the contents of 4000 and 4001 and store the sum at 4002 and 4003? It's the same question, but now since the addresses have changed, you'll have to make changes in your program. How many changes will you have to make? 1, 2, 3, 4. Every possible place you have hard-coded the address. These are rookie mistakes. These are the mistakes where you get errors on websites because people hard-code. When you start working in companies, your bosses will hate, your senior programmers will hate it if you hard-code numbers anyway. As much as possible, use indirect referencing, not direct numbers, because direct numbers work only on those locations. Indirect referencing is flexible and works everywhere. This is again a program to add 2000, 2001, 2002, 2003. I change the question. Write a program to add the contents of 4000, 4001, 4002, 4003. Same change if I am doing over here. How many places have I written the address? Only one. This is the only place which I have to change. So what can I do? I can make this a standard function to add contents of 2 memory locations and pass this number as a parameter to that function. Do you understand what I am saying? This is how programming is done in the real world. You don't write a program. You know, in your computer there is a program to transfer files. Now, you can transfer thousands of files from thousands of places to other places. For every transfer, there is no separate program. There is one program to do a file transfer. The starting address of the file source, starting address of the destination, the size of the file are sent as parameters to that program. It is one function that does all the operations. This can become a standard function to add any two numbers, whereas this will add only these two locations ka data. If you want to add, if you change the addresses, you'll have to change everywhere in the code. Code is written only once. It is modified again and again. You should write code that can be easily modified. That happens when you use indirect addressing. That is the advantage of using M. I'll give you more advantages. What happens? You added contents of 2000 and 2001. What if I tell you add contents of 2000, 2001 and 2002? Did you hear my question? 2000, 2001 and 2002. That means one more number that you want to add. All you need to do is INXH add M and this carry part. Put this procedure in a loop. First 𝗕𝗃𝗂𝗏 was 2000, INXH will make it 2001, next time 2002, next time 2003, next time 2004. Putting this much section in a loop will make you add a series of numbers. Nothing of that sort can happen over here. You've written addresses everywhere. If you want to add one more number, you'll have to write that code again, and then for one more number again. Obviously, to add 100 numbers, you don't write the code to add 100 numbers. You write the code to add two numbers and put it in a loop. That can only happen over here, not over there. See, don't get scared. I'm not trying to sell this to you. What I'm trying to make you understand is, the more you use indirect addressing, the better you get at programming. Life doesn't end at adding two numbers. There is so much more in programming to do, and those complex programs are only possible using M. So I use such a simple program just to make you understand how M works. You know what we'll do? This is what I do in the class. I never thought I'll be doing this in the video when I started, but I just get a feeling, I think doing that over here also will make sense. Let's write this program again. This time I want all inputs from you. Come on, I want you to dictate the program. I do this in the class. I just randomly erase the program, tell everybody to start writing the program and walk around, see what they're doing. What will happen? You'll make mistakes. That's what I want, my friend. Make mistakes, learn from them. Don't be overconfident, yeah, I know how to do it. And then when you sit in the exam, you can't write more than 2 lines. Make mistakes, learn over here. Come on, dictate. Once, I'll just give you the logic. Initialize C register as your carry with the value 0. Initialize 𝗕𝗃𝗂𝗏 with the number 2000, that means this is M. Take the first data in A, increment 𝗕𝗃𝗂𝗏, second number becomes M, add these two, answer is in A, check for carry, if there is a carry, increment C, if there is no carry, skip. Increment 𝗕𝗃𝗂𝗏, store A over there, increment 𝗕𝗃𝗂𝗏, store C over there. Please tell me, did you understand? Come on, dictate the program, come on, don't get scared. Come on, it's easy, it's add two numbers, how can it be difficult? Come on, start, initialize C, MVI C, 00H. Please tell me, did you understand? Initialize 𝗕𝗃𝗂𝗏 with the value 2000. LXI H, 2000. Is this much clear? Now, take the data pointed by M into A. Come on, come on, come on, come on. Move A, M. Excellent. Make 𝗕𝗃𝗂𝗏 go ahead. INXH. It is pointing to the next location. Now, this is M. Add these two. Add M. You added them. Now, check for carry. What's the idea? If there is a carry, increment C. If there is no carry, skip it by writing JNC, skip. This is skip. So when you reach skip, A has the sum, C has the carry. Increment 𝗕𝗃𝗂𝗏 so that it points to the next location. INXH, 𝗕𝗃𝗂𝗏 is pointing over here. Store the value of A over there. Move M, A. Again increment 𝗕𝗃𝗂𝗏, INXH. Now store the value of carry over there. Move M, C. Job done. Halt. Please tell me, did you understand this? Now, we go into our next program immediately. I'll just move the camera on this side. So, our next question is, write a program to transfer a block of data. Now, these are all block transfer programs. They are very typically asked in most universities. This is the program that runs in the background when you do a copy-paste. Because it's such a regularly asked question, many times they don't even give the details. They just say block transfer program because an engineering student is supposed to understand immediately on seeing the question, what do you mean by block transfer? So, here are the details. If they don't give, you got to assume this. There is a block of 10 bytes stored from 2000 to 2009. You want to transfer that block of data to 3000 to 3009. Copy, paste. Take the data from here and paste it over here. Now, the three things that you should realize when you'd want to do this program is, what is the source address, what is the destination address, and what is the count. The source address is 2000, the destination address is 3000, the count is 10. Now, bear in mind, my friend, the count given is always a decimal number, but we work in hexadecimal. Convert this to hexadecimal, that is 0A. You know how to convert decimal to hexadecimal, right? If you don't fret about it. This is not about that. Just take a calculator and do it. I hate using a calculator, and all the 4 levels of microprocessors I teach all the way up to Pentium 4, you never need a calculator because all of this is just easily done if you know your number conversions properly. I'll show you how to do it. Suppose they say block of 20 bytes. Okay, you want to convert 20 into hexadecimal. Divide the number by 16. 20 divided by 16. 1 is the quotient, correct? 4 is the remainder. So quotient and remainder, 1 and 4, that is your answer. 20 is 14 in hexadecimal. Let's take more examples. So what? 35 as an example. Convert 35 into hexadecimal. 16 into 2 is 32. So 2 is your quotient, 3 is the remainder, 23. 35 is 23 in hexadecimal. 100. Come on, 100. 16 into 6 is 96. 4 is the remainder. 6 and 4, 64. 50. 16 into 3 is 48. 2 is the remainder, 32, which is obvious. If 100 was 64, 50 should be 32, should be the half of it. 5. 16 into 0 is 0. So 0 is the quotient, 5 is the remainder. That's how 5 decimal is 5 hexadecimal. Tell me, did you understand it? If you didn't, no problem. I'm not even teaching that. That is not the purpose of this video. That is just too basic. I'm sure you learned it in lower semesters, or just don't rack your brain over it. Take a calculator and do the conversion. Knowing how to do that doesn't make you an engineer. That's just petty mathematics. The actual thing is to learn how to write programs of 8085. Anyways, in case you don't have a calculator in the exam, just wanted you to know how to do any conversion. Come on, for my sake, one more number. 64. 64 is 16 into 4. So 4 is the quotient and there is no remainder. So 0 is the remainder. 64 is 40H. 64 decimal is 40 hexadecimal. Please tell me, are you clear? So 10. 16 into 0 is 0. 10 is the remainder. 10 means A. So 0AH. Please tell me, are you clear? So that's your count. Now, you want to transfer the block of data from here to here. Take the data of 2000 into A. Store it at location 3000. Please tell me, did you understand? And now put this procedure in a loop and do it again and again. Now, how do you take the data of 2000 into A? LDA 2000 and then store it by STA 3000. Then take the next data by LDA 2001, STA 3001, LDA 2. Is that what you're going to do? No way. I told you this LDA, STA is petty stuff. That's childish work. You can do that. You'll keep only doing add two numbers all your life. You want to do big programs, get out of that and use indirect addressing. The more you use indirect addressing, the better you get to write bigger programs. You're going to do this by indirect addressing. So you'll need a register pair to point over here, another register pair to point over here. Let's say I use BC pair and DE pair. Initialize BC pair with the value 2000. Initialize DE pair with the value 3000. Initialize count in L because you already used BC and DE. Okay, be careful about the registers. A is remaining, HL is remaining, so I'm using L. So now what happens? Take the data pointed by BC pair into A, store it at the location pointed by DE pair, increment BC pair, increment DE pair, put the procedure in a loop, your program is over. Come on, let's do it. It's very simple. Come on. Initialize BC pair. LXI B, 2000. So what happens? BC pair becomes 2000. I have initialized BC pair with the number 2000. For BC pair, 2000 is the data. I will use it as an address at a later point. But first I need to initialize BC pair. Now initialize DE pair. Come on. LXI B, 3000. So I have initialized DE pair. Now initialize your count L with the value 0A. MVI, okay, it's a single register. MVI L, 0AH. So this is your source pointer, this is your destination pointer, and this is your count. Please tell me, is this much clear? Now do your main program. Take the data pointed by BC pair into A. L, D, A, X, B. Who gets what? A gets the, you know this instruction, right? A gets the data from the location pointed by BC pair. I repeat, A gets the data from the memory location pointed by BC pair. Because BC pair is 2000, A gets the data of 2000. I could have written LDA 2000 would have done the same thing, but that instruction cannot go in a loop because every time it will get data from 2000. Here I am saying get the data from the location pointed by BC pair. In the loop I will go on incrementing BC pair. So every time it will point to a new location, I will keep getting next data. Please tell me, did you understand? Now you got a hang of it, same thing. Now once the data is come in A, store it at the location 3000, no. At the location pointed by DE pair. So it can be any location in the loop. So store it STA D. Store A at the location pointed by DE pair. So you got the data from 2000, store it at 3000. Immediately increment both your pointers. Come on. INXD, INXD. Increment BC pair, increment DE pair. Please tell me, did you understand? So BC pair is 2001, DE pair is 3001. Now you're ready to do the next iteration. All you need to do is put this procedure in a loop. Who has the count? L. I have taught you how to make loops. We have done all instructions of 8085. Please see instructions first so that you understand programming better. So how do you make a loop? Decrement, DCR. D. DCR stands for decrement. Decrement D. I have a habit of writing DEC because all other processors call it DEC and INC, but only in 8085 they are called INR and DCR. But anyway, no problem. So DCR D, decrement D, decrement L. Okay. Cut. Okay. So to make your loop, you're going to decrement your count. Your count is in L, so you're going to decrement L. I've taught you how to make loops. You know how to make loops, right? DCR L, decrement L, which is your count. Now put this procedure in a loop by writing JNZ back. This is back. What is back? Back is a label. Now explain to me what happens over here. You take the data from 2000, store it at 3000. Increment BC pair becomes 2001. Increment DE pair becomes 3001. Decrement L. L was 10. Decremented becomes 9. 9 is not 0. JNZ means jump if not 0. So it's not 0, it will go back. Next time it will take from 2001, store it at 3001. Addresses will become 2002 and 3002. Count will become 8. Again not 0, will go back, and we'll keep doing this whole process 10 times. So from 2000 to 2001, 2002 to 2003, blah 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 blah. From 2009 to 3009, your 10 iterations are over, the block has been transferred, job done. How do you end the program? Halt, whatever, return, whatever you want to write. That's the end of the program. Please tell me, did you understand? Now tell me, this is a program to transfer 10 bytes. If I tell you write a program to transfer 20 bytes, what will change? The program will be the same, the count will change. 20, how do you convert 20? 16 into 1 is 16, 4 is the remainder, 14H. So your count will be 14, everything else will be the same. Source address and destination address. Instead of 2000 and 3000, if it was 4000 and 5000, what's the difference? This will be 4000, this will be 5000. So basically, this is a standard block transfer program. These three numbers will change. So that's what I said. When they give you a block transfer, either they'll give you these numbers or they just say, in Bombay University, they just say, write a block transfer program, because it's such a repeated question. If you don't know this, like, come on, that means you're not prepared at all. So even in practical exam, when you pick up the chit which says your question, it simply says block transfer program. So you assume these three. Assume the source block is at location 5000, destination block is at location 6000, block size is 25 bytes. Come on, 25, help me convert. 16 into 1 is 16, 9 is the remainder, 19. 19 is your count. Please tell me, did you understand? So will you be able to do a block transfer? Now here, I want to just tell you one thing. See, my friend, I don't want to confuse you, but it's my job to tell you everything. You understood this? I'm happy. Now just listen to what I'm saying. Instead of taking BC pair as the source, suppose you have taken HL pair as the source. Of course you can take. If you've taken HL pair as your source, this is DE pair as your destination, your count would then be in C, because you've used, you understand that, right? HL over there, DE over here, only BC is remaining, your count would be in C. So this will be HL, this is D, this will be C. That is fine. Your instruction LDAXB would not become LDAXH. Listen to what I'm saying. Just listen. I'm going off track. But as I said, I will not get sleep if you make this mistake in the exam. I'll feel guilty. Come on, look here. LDAXD is allowed. LDAXD is allowed. LDAXH is not allowed. Why? Because this is done by move A, M. Tell me, did you understand this? What does LDAXB do? A gets the data from the location pointed by BC pair. A gets the data from the location pointed by DE pair. You want A to get the data from the location pointed by HL pair. Now the location pointed by HL pair is called M. If you want A to get the value of M, you don't write LDAXH, you write move A, M. Please tell me, did you understand this? You understood this, right? You understand how I'm clearing my conscience? I know you've seen this program, you'll prepare it well and you'll go. Now I'd never support by hearting. I've never done it and I don't suggest anybody to do it. So for all you know, in the exam you'll use DE pair over here and BC pair over here, fine, you'll write the program. In case you use HL pair for any of them, you should not make this mistake. There is, if you understood what I said, tell me. There is STAXB, there is STAXD, there is no STAXH. This doesn't exist. You want to store A at the location pointed by HL pair. The location pointed by HL pair is M. To store A at M, you write move M, A. You don't write STAXH. Okay, just wanted you to know these. These are small mistakes. If you do programming all through the semester, I don't know at what point of time you'll start learning. When are you watching the video? If you're in the beginning of the semester, you'll realize these mistakes yourself when you're doing as and when you do programs. If you're doing this, watching this video just a day before your practical exam, then you have no time to gain experience. I have the experience, so I'm just sharing with you. These are mistakes people make, so I don't want you to make them. Anyway, let's go ahead. So that was a normal block transfer. Now you understood that. I want these two programs to get over within 5 minutes. Okay, 10 minutes we should be done with this video. Come on. Inverted block transfer. This block should be stored in an inverted form. That means 2000's data should come to 3009. 2001's data should come to 3008. 2009's data should go to 3000. You understand 1, 2, 3, 4, 5 should be stored as 5, 4, 3, 2, 1. Is that clear? Now how do you do that? Initialize BC pair with the value 2000, initialize DE pair with the value 3009, take the data pointed by BC pair into A, store it at the location pointed by DE pair. So your first byte has gone to the last location. Increment BC pair, decrement DE pair. Did you understand this? You will transfer from 2000, give me fingers, you will transfer from 2000 to 3009. Increment this, so you will transfer from 2001, decrement this, so from 2001 to 3008, 2002 to 3007, and so on and so forth. So your block will be transferred in an inverted manner. Please tell me, did you understand this? So what's the trick? Make one pointer at the beginning of the source, make one pointer at the end of the destination, increment this pointer and decrement this pointer. So instead of transferring like this, you're transferring the block like this. So the block will get inverted. I hope you understood it. Come on, will you be able to dictate the program? What are the three things? Come on. When somebody tells you on the just simple bland question, inverted block transfer, you need three things: the source address, the destination address, and the count. Assume source block from 2000 to 2009, destination block 3000 to 2009. Count. Assume count as 10, which is basically 0A, which will be there in L. Come on, give me your initialization and the program all by yourself. Try to speak out. What did I say some time back? The more you speak, the more you learn. This is somebody who's teaching this subject since 18 years and is telling you, I'm sure I know what I'm talking. The people who speak instructions learn the fastest. If you think of it, you'll always think you are right, and when you start writing them in the exam, people start writing rubbish. So speak instructions, you'll know where you stand. Okay, come on, there's no harm if anybody is looking at you. Let them think whatever they want to. Doesn't matter, you're learning for yourself. Come on. Initialize BC pair, DE pair and L. Come on, instruction. Initialize BC pair. 𝗓𝗏𝑖 D, 2000. Good. Initialize DE pair. 𝗓𝗏𝑖 D, 3009. Good. Initialize L. MVI L, 0A. Source address, destination address and count. Now, take the data pointed by BC pair into A. Yes, LDAXB. Correct. Store it from A to the location pointed by DE pair. STAXD. Good. Now increment BC pair. INXD. Decrement DE pair. DCXD. Decrement your count. DCRL. JNZ back. This is back. Please tell me, did you understand? Finish, job done. Halt, end the program. Is this clear? Now, the next one. So this was direct block transfer, this is inverted block transfer. Last one, block exchange. Exchange two blocks of data. So this data should come here, this data should come here. Students find this program very tough. Now, it's not tough at all, it's as easy as, you can see the space I've left, it's as easy as that, maybe 1 or 2 instructions more, that's it. What you're going to do is, don't think of exchanging two blocks, you will confuse yourself. Just tell me how to exchange these two locations. Let's say this is P and this is Q. Just exchange P and Q for me. If you can do this, all you have to do then is increment the addresses and put it in a loop. You'll be able to do the whole exchange. So let's do our initialization. Initialize BC pair with 2000, initialize DE pair with 3000, initialize L as your count with 0A. Okay. Take the data of 2000 that is pointed by BC pair into A. This is step number 1. Did you understand? Take the first number into A, step number 1. Did you understand this? Okay, focus here. Stop doing other things. So A is P. Transfer this data into some other register. Be careful, my friend, you're running out of registers. You've used BC, you've used DE, you've used L, you've used A. The only register remaining right now is H. See, from adding two numbers, very soon we've come to a situation where you're using all your 7 registers. Yeah, programs just keep getting bigger and better and fun. The more you learn it, the more you sharpen your tools, the more you'll feel like doing it. There'll be a time where you just don't want to stop programming. If you start enjoying it, it's an addiction. Anyway, so transfer this data from A to a free register like H. So H is now P, your first number. Are you clear? Take Q into A. So A is Q, this is your third step, this was your second step. So A has Q, H has P. Store from A at the location pointed by BC pair. So what will happen? You have put Q over here, at least this much, half of your exchange is over. From H, first take the number in A. So this was step number 4, this is step number 5. From A, store it at the location pointed by DE pair, that means which was P over here, that P has come into A, that P will come over here. Please tell me, did you understand? I'll show it to you. I'll show it to you again. No problem. This is P, this is Q. Okay? Take P into A. Transfer it into H. Take Q into A. Store it at this location of P. H, which had P, take it into A, store it at this location of Q. Did you understand this? For the last time, I'll do it again. I have patience. It's my job. I spend more than 50% of my life doing this. So I know I have the patience for it. It's up to you whether you have the determination to learn it or not. If you have the determination, I know how to make you learn, but you cannot give up so easily. Okay, let's do this again. Take the data of 2000, that is P, into A. You want to store that over here, but if you do that right now, you lose this number. So momentarily hold it into another register like H. So your P is safe. Now take the value of Q into A. You would say, why you take it into A? Store it directly. No, there is no instruction to transfer from memory to memory directly. You can transfer from register to register, register to memory, memory to register, but not memory to memory. So take this data. You understood that, right? So take this data Q into A. Transfer it at the original location of P. So you got Q over here. Half your job is done. Now where is P? P is in H. You cannot transfer from H directly over here. From H, take it into a register like A and then store it over here. Please tell me, did you understand this? Come on, let's do it together. Come on. Don't get scared. Okay, now what happens once you finish one exchange? Increment that you know, I know you know, increment BC pair, increment DE pair, decrement L and make it a loop. Once your job is not to exchange two blocks, your job is to exchange two locations. Once you exchange two locations, put it in a loop, the loop will exchange the two blocks. Just get to exchange two locations. Okay, let's do it together and stop being scared. Come on, initialize BC pair, 𝗓𝗏𝑖 D,2000, good. Initialize DE pair, 𝗓𝗏𝑖 D,3000, good. Initialize L, MVI L,0AH. Good. All your initialization is over. Now, take the data pointed by BC pair into A. LDAXB. So, A is right now P. Please tell me, did you understand this? From A, transfer it into H. Move H, A. So, H is right now P. Are you clear? Now, take the second data pointed by DE pair into A. LDAXD. Now, A is Q. From A, store it at the location pointed by BC pair, STAXB. So that means location pointed by BC pair, which means which was initially P has now become Q. Did you understand this? This location has become Q. So half of your exchange is over. Now the question is, where is P? P was there in H. From H, get it back to A. Move A, H. You got it back to A. From A, store. So as of now, A is P. From A, store it at the location pointed by DE pair, STAXD. So location pointed by DE pair, which was originally Q, will now get P. So you have managed to do your full exchange. P and Q have been interchanged. Increment BC pair, increment DE pair. Put the procedure in a loop by decrementing DCR, L is your count, J, N, Z, back. This is back. When your loop ends, your whole block has been exchanged. End the program by writing halt, no space, so I'm writing on the side. Okay, for the last time, what did we do? Come on, come on, come on, come on. Don't be scared. Don't be scared. You cannot learn programming by watching someone program. If someone's, I tell students, someone just going on writing programs on the board and telling you, okay, you understood, and you say you understood, you both are just fooling each other. The ideal way to learn programming is to write. That's what we do in the class. I do one program, then I teach the logic and people do the second one. This is not a class, but we can do this again. This time I want full inputs from you. It should be as if you are dictating to me. Okay, let's see whether we can make that magic happen. Come on. Initialize BC pair, DE pair in L. Come on. Now, take the data pointed by BC pair into A. LDAXB. Transfer it into H. Move H, A. Take the data pointed by DE pair into A. LDAXD. Store from A at the location pointed by BC pair. Good, good, good. STAXB. Good. Transfer from H to A. Move A, H. From A, store it at the location pointed by DE pair. STAXD. Done. Exchange is over. INXB. INXD. DCRL. JNZ. Back. This is back. That's the end of the program. End the program by writing halt. That's it. Tell me, did you understand this? So, these were initial programs of 8085. I would love to do 30, 35, 40 programs. But making videos for each of them is a very time consuming process. So what I'm doing is I'm nitpicking and picking up the programs which explain most of the interesting logic, which make you learn something new. Once you understand those, you pick up other programs. There are really good books on programming. I'll put up all my material, of course, on the app, but otherwise also there are really good books. There is Mazidi, there is 𝗬𝗵𝗿𝗁, wow book for 8085 programming. Then of course the good old 𝗕𝗵𝗿𝗁, very good book, and so on. I'm sure you know the books of 8085. Pick up any book of 8085, you will get real good programming examples. The idea is once you understand, once you get the hang of programming, do a few programs, you will understand more. I'll still put on more videos. Of course, I will put as many as I can. The theory topics which I want to do first, but I will be putting up more videos of programming. I hope you enjoyed learning this. Practice more programs by yourself. Wish you all the best. Do well.